Hi, in this video we're going to look at how we derive the formula for loan repayment. This is we're assuming we have borrowed a sum of money, say a mortgage, and we make monthly payments over a number of years. How much would be the regular monthly payments that we would have to make to pay off the loan? Now, there are two ways of doing this. The way I'm showing in this video is a bit long-winded, but it's pretty descriptive and clear as to how we arrive at the formula. The second method involves the concept of present value. It will arrive at the same formula for the monthly payments with slightly fewer steps. But I think this is much illustrative as to the process that how the calculation is made. Now, for this purpose, we assume we have borrowed an amount F, which we call it the amount of the loan, and we have an annual interest rate of R. R is not necessarily the annual interest rate, but it is the interest rate for the period of payment. For example, if we are making monthly payments, then R would be the annual interest rate divided by 12. If we make quarterly payments, then R would be the annual interest rate divided by 4. But for the rest of this video, we assume we are paying our loan off monthly. So R would be the interest rate, the annual interest rate divided by 12, which is roughly accurate, but perhaps it's not 100%. N is the number of payments that we will make. For example, if it's a 1-year loan, it will be 12. If it's a 3-year loan, it will be 36, etc. And P is the amount of the monthly payments that we make. It's the regular payments of P amounts. And we want to work out how much this regular payment is going to be. So this is how we approach this. Supposing we borrow the amount F. So at the beginning of month 1, the amount that we owe will be F. It's obvious we've borrowed F, so we owe F amounts at the beginning of month 1. Now, at the end of month 1, how much do we owe? We owe F plus the interest of 1 month on F, which would be F plus RF. If I factorize F out of that, I'll get F times 1 plus R. Now, how much will we owe at the beginning of the second month? At the beginning of the second month, we will owe this amount, but we make a payment. So it's this amount minus a payment P, which we don't know what it is at the moment. This is what we're trying to work out. So how much would we owe at the end of the second month? We will owe this amount plus the interest on this amount, which will be R times all of that, which I have bracketed here. Now, if we multiply R, open up the bracket, and do some algebra, we will arrive at the formula that at the end of month 2, we owe F times 1 plus R squared minus P times 1 plus R. So this is the total amount we owe at the end of month 2. Now, at the beginning of month 3, we make a payment. So we will owe what we owed at the end of month 2 minus a payment. And if we continue do the algebra at the end of month 3, we will owe this amount plus R times this amount, which is, this gets longer and longer, the formula. So at the end of month 3, we will owe this amount. And here I've multiplied the R into the bracket, and we do a bit of algebra. And we arrive That was a bit early, beginning of month 4. We arrive at this amount that we owe at the end of month 3. Now, at the beginning of month 4, we will owe this amount minus a payment of P. And we do the same calculations again and again up to month N. At the end of month N, we will owe this amount. So this will be F times 1 plus R times N. If you note here, it was for end of month 3, it was 3, 2, 1. So these indices keep declining. So at the end of month N, we will owe this amount. Now, then we make a final payment of P, which is here, minus another P, and this will clear the loan. So after all of that, we will owe 0 amounts. Now here in this equation, which I've now highlighted in red, we know F, we know R, we know N, and we need to work out P. Now if we come back here, I've rewritten the equation, I've factorized the P, and I've rearranged the terms so that the terms that are multiplied by P will be written as 1 plus 1 plus R plus 1 plus R squared up to 1 plus R to the N minus 1. And this index is N minus 1, but here we have N terms. Now we notice the expression in the bracket forms a geometric series with the first term 1 and the common ratio 1 plus R. Now the formula for the n terms of a geometric series is given below, where S is the sum, A is the first term, and Q is the common ratio, N is the number of terms. If I plug my values into this formula, I'll get S is equal to P. Obviously P is factorized out of the sort of bracket, and the expression in the bracket becomes the sum of a geometric series. So S will be equal to P times this expression there. Okay, we arrive at this equation to solve. Now, if I take the terms including P to the other side, I'll get this expression. And from here, I can calculate that P is equal to this expression there, which is our monthly payments. Right, as an example, now this is the formula we arrived at, and this number here is calculated by Excel spreadsheet. So here, if I borrow £1,000 at a 10% interest rate and want to pay it over 1 year, 12 equal payments, that month that the formula gives us is £87.92, and this is what Excel calculates. So if I say if we want to borrow £2,000 at a rate of say 7%, and we want to pay it over 2 years, monthly payments would be $89.55, and this is what Excel calculates. Now, obviously, Excel is also using our formula. One caveat: the reason the number you get from Excel is a negative number, it really indicates that you are paying the money out. So because this formula is basically used by and for accountancy purposes, so outgoing amounts are indicated as a negative number. I hope you enjoyed this video and it has been instructive. Please give it a like and subscribe, and I'll see you in the next video.